the lucky. And this one is a saturated solution okay, this one is a major. I'm glad we brought this one up. I got them reversed. It was a typo on the paper. It was supposed to be 0.00
2, and then
2 molar,
yeah.
and okay. This is the question, and this is another one. I'm glad we waited until now. This is another one I want to discuss in lecture because this was a typo. I got these molarities swapped, and this is in the these are the way it was. The other way is impossible, and otherwise this is one of those gimme questions. This is even more of a gimme question than the one on the pH for number 9. And that we have to take into account. This is a solubility product equilibrium. And so the solubility product is always, I'm going to start with this generic solid, is going to dissociate into cations plus anions. And the stoichiometry is commensurate with the formula. Okay? And so all we need to do is find the KSP, the mass action expression. Now, does the solid appear in the mass action expression?
No.
Why not?
It's a solid.
It has unit activity. Exactly. It doesn't matter how much solid is there. It could be just a grain that's barely detectable with a Tyndall effect and a powerful laser, or it could be a mountain of solid with a little dish of water in it. It's a saturated solution. Saturated solution means it has reached equilibrium and these have their maximum concentrations. Okay? And so now all I need to know is that KSP is equal to what? What's the ion product here?
The reactants multiplied divided by the.
Well, no, the reactants aren't going to occur. It has unit activity.
Sorry,
The products.
multiplied divided by the
So
reactant.
it's going to be C3 plus times what?
A minus to the cube root, or cube.
Yeah. Stoichiometric coefficients are the exponents in the mass action law. And so at this point, we're just plugging and chugging because I already have these two values. So this is a very straightforward. And by the way, you get most of the credit for this. If you just simply write this out, you've got the problem already solved. It's just a simple mathematical. And if you make a mistake there, it's just not going to knock you that much. And so this is equal to 0.002. Well, I'm going to rewrite that as 2 times 10 to the negative what? 3. Okay. And I'm going to rewrite this as that is 3 times 2 times 10 to the negative 3 times 3 times 2 times 10 to the minus 3, and that is cubed. The reason I did that is because This is 2 times 10 to the minus 3 cubed times 2 times 10 to the minus 3, which is equal to 3 cubed times 2 times 10 to the minus 3 to the 4th power. Okay? And at this point, what's 3 cubed?
27.
Equals 3 cubed is what?
27.
27.
27. What's 2 to the 4th power?
16.
16 times 16 times 10. What's 10 to the minus 3 to the 4th power?
So then you 12.
To the negative 12. Okay, and now I'm going to move that up just a little bit. We can go on and solve that a little further. I'll go get my scratch paper out. And 27 times 16, 7 times 6 is 42. 2 times 6 is 12, and 4 is 16. And 27 is 2, 6 and 7 is 13. 4, 32. So this is equal to 432 times 10 to the minus 12. And now I just got to bring the decimal point back 1, 2 more. And what do? So that's equal to 4.32 times 10 to the what? When I bring the decimal point this way,
Negative
I move it to the left. What do I do with the exponent?
10.
It's gonna,
You had 2.
it gets more positive. So it's because, so I'm gonna take, it's gonna be 10 to the minus what?
10.
Okay, so the majority of the problem was you should be able to write this equilibrium and write the mass action expression. You get that right, you got most of the problem. Beyond that, it was just a mathematical exercise, just sort of for your entertainment. It's like solving a puzzle, it's satisfying. I have a weird idea of what's satisfying, don't I? Okay, so does that answer everybody's questions? Is that a wrap?
That's a wrap.
That's a wrap.